Alrighty, let's go ahead and look at some literal equations, okay? So essentially what this kind of boils down to is being able to take some kind of formula that has variables, multiple variables in it, and kind of solving for one of the variables. So say you had the formula for the area of a triangle, which is 1/2 base times height. So I have, and just write it up here. So area equals 1/2 base times height. Okay, what if instead of knowing the base and height of every triangle, say I have a bunch of triangles and I know the area and the height, and I wanted to be able to find the base. Well, instead of plugging numbers in and then solving for b every single time, I could just solve this equation here for b, and if I got b equals blah, then I could just plug those numbers in and I wouldn't have to worry about the solving piece every time. So that's kind of where this lesson stems from, okay? So a quick recap on combining like terms. Remember, like terms have to have the same variable, which is what we usually know. Exponent is sometimes forgotten about. Okay, so same exponent. So here we have our x's, right? 5 minus 10 would be negative 5x, and then we combine our numbers. 4 plus 1 is 5, okay? So that's kind of what we're looking at here. Okay, so essentially what we're going to do when we're looking at these problems is we're going to treat everything like a number except what we're solving for. Okay, so let's go ahead and zoom in on number 1 here. So on number 1, I'm trying to get y by itself, right? So let me highlight y for us. So there's y. I'm going to treat everything else like a number. So the x that's sitting out front is like a number to me. If that was 5 plus y, right? So if I had 5 plus y equals 7, I would subtract 5 because that would be my opposite operation. So instead of 5 plus y, I have x plus y. So if x is positive, my opposite operation is subtract x. Subtract x. Okay, I'm left with y by itself over here equals 7 and x are not like terms, right? Because they don't have the same variable. So I just write what I see, 7 minus x. And as soon as you have the variable you're looking for by itself, then you're done. All right, let's look at number 2. Okay, again, I'm trying to get y by itself. So to get rid of negative x, my opposite operation would be plus x, right? Opposite of subtraction is addition. So I add x over here. Okay, so those cancel. I'm left with y equals, and again, negative 2 and x are not like terms, so I just write what I see. Negative 2 plus x. Okay, so same opposite operations apply here that applied before. Okay, so now I'm trying to get y by itself. So say I had 3y equals 2. If that was the case, we know that 3y is multiplication, it's 3 times y, and I would divide by 3. Okay, so same rule applies here, except now instead of having 3 times y, we have x times y. So opposite operation would just be to simply divide by x on both sides. So my x's cancel. I'm left with y equals 2 and x don't simplify, so I just leave it just like that, 2 over x. Okay. The hard part about these problems is sometimes the answers look kind of messy like that, like the 2 over x. But I assure you, if you're following the right opposite operations, you're doing them correctly. Okay. So let's go ahead and look at number 4. So y over x. Remember, anytime I say over, that's like division. So this is y divided by x. So my opposite operation to get rid of x would be multiplication by x. Okay, so my x's cancel top and bottom. I'm left with y on the left-hand side. 10 times x is very simply 10x. Okay. All right, so those are our examples. Go ahead and try these 4 problems. So go ahead and pause, try these 4 problems, and then you can play the video when you're ready for me. All right, if we're trying to get y by itself, x is positive, so I want to subtract it. So y is by itself now. Negative 5 and negative x are not like terms, so I just write them like I see them, negative 5 minus x. Done with that one. On number 6, x is trying to get y by itself. X is negative, So opposite operation would be add it. So I have y equals 4 and x are not like terms, so I just write 4 plus x. Now that one's done. Number 7, okay, y or xy is like x times y. My opposite operation would be divide by x. And I'm left with y equals 17 over x. Okay, and then last but not least, number 8, y over x is division, so I need to multiply by x on both sides. And I'm left with y equals negative 1x. Okay. All right, let's look at our second page here. All right, so these are getting a little more complicated, okay? So now we have, excuse me, now we have more than one operation happening here, okay? So we kind of have to be careful with these. Remember, when you're solving an equation, you start furthest away from what you're solving for and kind of work your way towards it. So if we're trying to get y by itself, let me zoom in here a little bit more. Okay, if we're trying to get y by itself, I need to get rid of both the 2x and the 4 that's sitting in front of y. Okay, so we start furthest away. So let's start with this 2x out here. So opposite operation of a positive 2x is subtract 2x, right? I want to take the whole term. I don't want to leave the x. I want to take the whole thing. So I subtract it off. I'm left with 4y over here. We'll deal with the 4 in a second. Negative x and negative 8 and negative 2x are not like terms because they don't have the same variable. So I write what I see, negative x minus 2. Oh, sorry, I keep saying that wrong. Negative 8 minus 2x. There we go. Now I need to get rid of this 4 that's in front of y. Remember, 4y is like 4 times y, so my opposite operation would be divide by 4. And anytime you do division, you have to make sure it's done to every term. So that's kind of the tricky part to remember here. When we're adding and subtracting, we just do it once on either side. When I'm multiplying or dividing, I have to make sure it gets done to every single piece, okay? So now our 4's cancel, and I'm left with y by itself. That's what I wanted. Negative 8 divided by 4 is negative 2. Negative 2 divided by 4 is negative 1/2, or you could always put negative 0.5 if you wanted to, x. And that's that. All right, let's look at one more. All right, so trying to get y by itself here. So first thing I need to do is get rid of that negative 4x. Since it's negative, my opposite operation is add 4x to both sides. And I'm left with negative 3y equals 12 plus 4x, right? 12 and 4x are not like terms, so they just get written as you see them. Okay, I need to get rid of that negative 3. Remember, negative 3y is negative 3 times y, so I want to divide by the negative 3 to every term. Okay, so my negative 3's cancel. I'm left with y. That's what I wanted. 12 divided by negative 3 is negative 4. 4 divided by negative 3, that's going to end up being a negative number, right? So I put my minus in, and I leave 4 over 3 just like it is. If you wanted to make it 1.3 repeating, that's fine. I just like to leave minus fractions if they're not too messy, okay? So just like that. All right, so let's go ahead and try, let's just do 11 and 12. We don't need to do the rest of them. Let's just do 11 and 12. So pause the video, do 11 and 12, and then you can go ahead and watch me. All right, trying to get y by itself, I add 4x. So I have negative 5y equals negative 10 plus 4x. Last time I'm getting y by itself is divide by negative 5 on every term, okay? Then I have y equals negative 10 divided by negative 5 is positive 2. 4 divided by negative 5 is going to be negative, and 4 over 5 doesn't reduce, so I'm just going to leave it 4/5 x. That would be negative 0.8 as a decimal. All right, number 12, getting y by itself, I subtract 6x. So I subtract that whole term, not just x, not just 6. So 4y equals 16, and 6x are not like terms, so just write what you see. And then getting y by itself, I need to divide by 4 on every term. And I end up with y equals 16 divided by 4 is 4. Negative 6 over 4 reduces to negative 3 over 2 x. And you could make it negative 1.5 if you wanted to. All right, that's your lesson on literal equations.